Second. All right, we are live on YouTube, and I am so excited to have this broadcast with some very special paleontologists. So my name is Ann Werda. I am the executive director over at Burpee Museum, and this is my colleague Josh Matthews.
Welcome everybody. This is our 23rd PaleoFest here at the Burpee Museum, and it has been in the past, obviously, due to the COVID pandemic. So this is the first time we're doing everything virtually from here at the museum. So we're going to have talks today. We'll have research lectures tomorrow and Sunday from all the guest speakers. We'll have activities, all kinds of cool events happening throughout the museum virtually. So I'm glad you guys are here. We got, as of now, we got Spencer. We got 5 paleontologists in here. We're going to kind of go speaker by speaker, and we're going to have them introduce themselves, talk a little bit about what they work on, and then we're going to get some questions. And before we get started, I didn't do this morning, but I just wanted to wish Spencer a happy birthday.
Thanks, Josh.
So we'll get started. Okay, let's get started with you, Scott.
Oh.
Scott Williams, tell us a little bit what you do.
Okay. Hi, everybody. My name is Scott Williams. I'm the interim exhibits director and paleontology lab and field specialist here at Museum of the Rockies in Bozeman, Montana. I've been doing paleontological field work for over 20 years now. I first went to the Hell Creek Formation in the summer of 2000. I worked at Burpee Museum for a little over 14 years. Did a variety of things there. Was the fossil prep lab manager, collections manager, exhibits director, ran PaleoFest for several years. I've done a lot of work in the Hell Creek Formation, which is the latest Cretaceous formation that dates between 66 and 67 million years old. That's where you get your Tyrannosaurus rex and Triceratops and Edmontosaurus, the big duckbill. Was part of the team that discovered the Hanksville Burpee Quarry, which I think Josh will probably talk about at some point. That's a late Jurassic sauropod-dominated bone bed. The sauropods are the big long-necked dinosaurs like Apatosaurus and Diplodocus and Camarasaurus. Here at the Museum of the Rockies, I've done a lot of work over the last few years in the Judith River Formation. So that's older. That's about 10 million years older than the Hell Creek Formation, and that's where you get animals or dinosaurs like the Brachylophosaurus, Displetosaurus. You can get some of the horned dinosaurs there, Spicolipes, or I don't remember if I pronounced that one right or not. And also have done some work in the Bear Paw Formation. So Bear Paw is between about 70 and 75 million years old formation. It's a marine formation when the Western Interior Seaway, which at one point had bisected North America, expands again and covers about half of Montana. So we have all these marine shales that we find the long-necked plesiosaurs in. Like, for example, right here I have a cast of one of the plesiosaurs. This is a kind of nectes. So this is one of the long-necked plesiosaurs. It's actually related to Elasmosaurus. You also get the big mosasaurs, the big marine reptiles, basically large ocean-going lizards, like you see maybe in the Jurassic World movies, if you've seen those. And I've also done a fair bit of work in the Two Medicine Formation. So Two Medicine, again, about a little over 10 million years older than the Hell Creek, but you still get relatives of T-Rex. You get Displetosaurus, you get the duckbill dinosaur Maiasaurus or Maiasaura, and we have egg sites there. Like here I have a cast of a Troodon egg, dinosaur egg, very famous location. So those are kind of the things I've worked on in the past and continue to work on.
No, we're not.
All right. Actually, I'm gonna jump back to myself because I realized I didn't actually give you guys a proper introduction to myself. I am the director, Josh Matthews. I'm the director of paleontology here at the Berkeley Museum of Natural History. And I, when Scott moved out to Montana a few years ago, I took over the position running the paleontology department here. So I started here with the Burpee with Scott back in 2004, just as a volunteer, working a few hours a week, and then went out in the field with Scott where we found Homer, our multiple specimen Triceratops bone bed, and that kind of snowballed from there. Scott and I have been working together pretty much ever since, just about every summer out in Montana. And then in 2007, he and I and a small crew from here went down to Utah, and that's where we found that what's now called the Hanksville Burpee Dinosaur Quarry. I believe it's probably one of the largest continuous dinosaur bone beds in the world, in North America for certain. There's a lot of bone beds up in Canada as well. However, the bedding unit at the Hanksville Burpee Dinosaur Quarry goes for at least a mile to the northeast. We're only working a small section of the quarry, about the size of a football field or so, which is maybe not quite, maybe half a football field. But still, we've got over 20 dinosaurs in this quarry, mostly sauropods, but we got a number of other species as well. I think we're up to 8, maybe 9 different taxa at this quarry. So we've been working out there in Utah since 2007. And for my research, the research that I do here at the Burpee currently, I'm finishing up my PhD at Northern Illinois University in the Department of Biology. I work with microvertebrates. So what I mean when I say microvertebrates are the smaller animals that are basically living underfoot, beneath the dinosaur's feet. So when most of us, or a lot of us, think about paleontology, the first thing that comes to mind are the dinosaurs. But paleontology encapsulates everything, all of ancient life, from the tiny microbes to the plants to the bacteria up to dinosaurs. So beneath the dinosaurs' feet, you have things like mammals. You have salamanders and frogs and lizards and snakes. In the waters, you have fish and sharks and freshwater skates and rays. So what I'm doing is I work out in the Hell Creek Formation where we found our juvenile T-Rex Jane and our Triceratops Homer. And out there, the Hell Creek Formation is a geological unit that represents the very end of the Cretaceous period. So Scott mentioned it a little bit ago. And right at the top of that Hell Creek Formation is where the asteroid impact happened, which ended the reign of the dinosaurs. So it's about 450 to 500 meters thick. So for my research, I'm sampling these microvertebrate sites from, so if the Hell Creek is about this wide, I'm sampling it from the lower portion, the middle portion, and then the upper portion. And I'm looking at these fossil communities and seeing how they change throughout the last 1.5 to 2 million years of the Cretaceous period. So, and then within that assemblage, I'm actually pulling the amphibians out, and I'm looking at salamanders and frogs to see if we can see any fluctuations that occur with climate patterns during the Cretaceous. Because even today, modern day environments, if there's climate change or pollution, waters are polluted, amphibians tend to be one of the first things that feel those effects because they breathe through their skin. So if there's any polluted waters, they're gonna feel that. So I'm gonna look to see if there's any signals in population dynamics within amphibian assemblages within. So those are what I study now. Again, we work at the Hanksville Burpee Quarry. So once I kind of finish up my dissertation, I'll start focusing more on that quarry because it's a large quarry. We got a number of different species of dinosaurs. In addition to possible mammal burrows, we got freshwater bivalves, petrified wood, and a number of other organisms there. So there's a lot going on here. So that's kind of what I've been doing here at the Burpee for the last 14 years, and then the microvertebrates about the last 5 years. But that's what I'm doing. So I'm gonna throw it over to Dr. Tom Holtz now, and a little bit about what you do there, Dr. Holtz.
And Dr. Holtz, while you're on, and I'm sure Scott could weigh back in on that, we did see one comment that came across that I put up on the screen about our friend the Nanotyrannus. I want to know if that's, quote, still a thing. The other thing that we've got another student that wants to know how many dinosaurs you find in a year. So I'll let you take over. If you can weave some of that into your introduction, that'd be great.
Sure. So I'm Dr. Tom Holtz. I'm a dinosaur paleontologist at the University of Maryland, and I also have a research position with the Smithsonian's National Museum of Natural History. And yeah, I've studied dinosaurs since the late 80s and obsessed with dinosaurs since the latest 60s or beginning of the 70s, ever since I was a little kid. But my main research area, or my main research topic, is the carnivorous dinosaurs, and especially tyrannosaurs, so T-Rex and its relatives. I'm interested in the evolution of the group, their ecology, how they interacted with each other and with the environment, their behavior, their locomotion, and pretty much anything about them. But I love the whole paleontological world, the whole fossil world. The current research that I'm talking about later this meeting has to do with meat-eating dinosaurs in their ecosystems and how it changed over time. And the Nanotyrannus question comes up. So is Nanotyrannus a thing? And that depends upon what you mean by is a thing. So is Nanotyrannus a distinct species from Tyrannosaurus? So that's the question most people think about. So we have some skeletons, like a skull that's in the collections in the Cleveland Museum, and most famously Jane, the skeleton in the Burpee Museum, and there's a couple others around there, of 11 to 13-year-old, based on their bone the texture inside their bone, the number of growth rings. Individuals, they're definitely a type of tyrannosaur, but are they something different than a T-Rex? Now, there are some people who argue that they are different, and they have some interesting points. But personally, my interpretation of the data is that the best solution is that this is just what a T-Rex looks like when it's a young teenager. Because all animals change in proportion and so forth as they get older. And remember, a baby T-Rex is going to come out of an egg like this big, like a soccer ball or a 2-liter bottle of soda. And it's going to have to grow up to an animal that's 40 feet long and basically the size of a killer whale. And that's a lot of growing to do. And you can't be the same animal between a little guy and a giant like that. And so what I and some others think is that in terms of the way they interacted with the environment, in terms of the animals they hunted, in terms of how they got their food, a young Tyrannosaurus, like Jane, was effectively a different kind of animal, even though biologically it's the same species. And if it lived to grow up all the way, if Jane had lived to grow up all the way, it would have looked like Sue and Scotty and Stan and the other adult T-Rexes. But in terms of the way it ran, what it hunted, how it hunted, it was a different kind of animal. Oh, and there was also the question about the number of dinosaurs. I don't find that many dinosaurs a year. I don't get out as often as I'd like, especially with the pandemic. Although normally every summer I dig with the folks of the Burpee Museum out in Montana. But about 40 to 50 new dinosaur species are named every year. And so that means, and that's all the whole world. So that means that we're finding, we collectively, paleontologists and people who work with paleontologists to find fossils, are finding new dinosaurs all the time. And remember, dinosaurs are just a tiny fraction of ancient life. So the number of new fossil species found every year, when we include mammals and trilobites and ammonoids and so forth, is huge. Hundreds and hundreds of them.
Fantastic. Thank you so much, Dr. Holtz. We're going to switch over now to...
Yeah, let's go to Dr. Julie Meechan, who, let's transition a little bit from dinosaurs, and Dr. Meechan is going to be presenting on some really cool research she's been working on this weekend. So, how you doing, Julie?
So I'm good. So I am not a dinosaur paleontologist. I'm actually a Pleistocene or Ice Age mammal paleontologist. I focus on the big carnivores generally. And so here at PaleoFest, I'm actually presenting on a little previously frozen Ice Age mummy, a little wolf mummy. And so that's what I'll be talking about. at PaleoFest. The other many things that I work on include things like saber-toothed cats. You can kind of see my little saber-tooth behind me. And I've given a talk on saber-tooths in previous years at PaleoFest. And I also work on lots of other dogs. So I work on things like dire wolves and coyotes. From the two sites that I work mainly on, which are Natural Trap Cave, which is also in Wyoming, where they find a lot of dinosaurs, but I'm working on much later mammals. And then the other big site that I work on is the Rancho La Brea tar pits. But I'm happy to answer lots of questions about Jur, our little wolf pup. When she was found, I know people are asking if she's cute. Well, she's missing a lot of the hair on her face. So that might not make her so cute to some people, but I still think she's cute. We have this little picture that's straight on her face, and she's got this adorable little snarly face. So I think she's cute, but that's just me.
That's fantastic. I think beauty is in the eye of the beholder. So I think snakes are cute.
They are.
All right, Dr. Spencer Heller.
Hey, I'm Spencer Heller. I'm from the Field Museum of Natural History in Chicago. I've known Josh and Scott for a really long time. I think I've known Josh for almost at least 10 years now. So I started out doing sort of dinosaur stuff in school, and then mostly now my main science question is about how things evolve, and especially how things don't evolve. So when you evolve, your whole body doesn't evolve at once. Little pieces of your body can evolve by themselves, and then species change over time. But sometimes those little pieces of your body are really, really interconnected. And that can because they are controlled by the same gene. So genes are the directions that make up your body. And so sometimes the same direction can be applied to two different parts of your body. Sometimes two different parts of your body are involved in the same function. So what that means is that if I'm going to change one part of my body, sometimes another part has to change along with it. And that can stop evolution from happening in some direction. So this is a fake example, but I like to use it because it's easy to visualize. But let's pretend that the same gene controls whether or not you have a head and how big your feet are. And for some reason, it would be really great for humans to have really big feet. And so you want to evolve your feet to be really big, but then you don't have a head because it's controlled by the same gene. And you can't be walking around without a head. And so you will never be able to evolve big feet. So that's an example of a direction in evolution that cannot happen. And so to do that, I study a whole bunch of different animals. I've looked at dinosaurs, I've looked at birds, especially flightless birds. I've looked at beetles even. And then most recently, I'm looking at mammal ancestors. And since we're going to be talking a lot about dinosaurs, I might as well talk a little bit about mammals. And mammals come from these animals that look kind of more like reptiles. They almost look dinosaur-ish, but some of them look really crazy. A few of them, this is a little bit of a janky setup, but you can kind of see that. A few of them look like a walrus and a dinosaur had a baby. And then a couple of them have this big sail, and some of these guys sneak into dinosaur books. Especially kids' dinosaur books. And so if you see that big sail-backed guy on all four legs, he's not a dinosaur. It's a thing that's eventually going to be a mammal. And specifically what I look at is the evolution of mammal arms and legs. So we can do whole bunches of things as mammals with our arms and legs that other groups of animals can't. So bats can fly with their arms. You can climb with your arms. You can swing in branches with your arms. You can dig with them. Swim with them, all kinds of stuff. And as a group, we can do much, much more with our arms and legs than other animal groups can. And we think that the reason why we can do that is because of how our backbone evolved in a really special way. And so I'm doing that by turning the shape of bones into math and looking at the math behind that shape.
That's fantastic. Very good. Yeah, I'll switch up.
And we got Dr. Hone.
Hello.
That's a little bit what you.
There we go. Hello. So I'm Dr. Dave Hone. I'm a paleontologist at Queen Mary University of London in the UK. I do lots of different things. In fact, a lot of my work is very similar to Tom Holt's, and we've collaborated a lot of projects together. So I also do a lot of stuff on big carnivorous dinosaurs like Tyrannosaurs and Spinosaurus. I do on some smaller dinosaurs like Velociraptor. I'm also very interested in behavior and ecology and evolution and what they ate and how they ate. And I've also done quite a lot of work on sexual selection, so communication and the evolution of things like the crests that you get in ceratopsians like Triceratops, and the plates you get in Stegosaurus, and the horns and frills and weird things you get in all kinds of other dinosaurs. And I also work on pterosaurs, the flying reptiles that everyone thinks are dinosaurs but aren't. I've done a fair bit of work on them as well. I kind of half carnivorous dinosaur, half pterosaur researcher. And that's all I'm going to say about myself, and we'll try and answer some questions.
Yep, we're good.
All right. Well, let's get some questions here. Yeah, Maya has a really good question. So I'll let any of you want to jump in to field this. Could prehistoric creatures have gotten diseases that humans get today?
Yes, well, Scott's nodding furiously, but the same kinds of diseases, I doubt they'd get COVID or the common cold or chicken pox. But the same kinds of diseases, bacterial infections, fungal infections, some kind of parasitic worms and nasty stuff like this that we get, absolutely. And we see evidence of that. We see damage and injuries to bone. We see healing. We see infections on bones. And evidence of things like cancers all turn up. So it's obviously very hard to go, oh, this dinosaur had this infection, exactly. But we can see when things have gone wrong and they were definitely ill.
I know that tuberculosis is one of those diseases that is found in prehistoric mammals. So that is a disease that animals could get that we also can get.
And Julie, this one would be for you.
How I was motivated to study Ice Age animals. So how I was motivated is I actually grew up in Florida, which is a state that has an incredible number of Ice Age mammals. And I did my undergraduate degree at the University of Florida. And I worked in the Florida Museum of Natural History. And the Florida Museum of Natural History just has an incredible number of Ice Age mammals in the collection. So just going through the drawers, looking at them, especially, the Smilodon, the saber-toothed cats really got my attention. So I always knew that I wanted to work on mammals ever since I was a kid. I actually wasn't a dinosaur crazy person. I was a mammal crazy person. So I have always been interested in mammals, and the Ice Age is like the great time for mammals. At least the Tertiary and the Quaternary are both great times for mammals, but I love Ice Age mammals.
Yeah.
This is quite the chat here. I think you're really competing with the dinosaur folks. Yeah. There's a lot of questions about the wolves. So people are asking, how old and where did you find the pups?
So the pup was found in July of 2016 by a gold miner in the Yukon. And he thought he actually just had like an animal that might have died 100 years ago. And when the Yukon paleontologists went out there and looked at it, they were like, oh no, this is much older. So we found her and we knew she was old. And then how old was she when she died? She was about 8 weeks old, about 6 to 8 weeks old when she died. So a little baby.
Wow.
Yeah. All right. I think we got most of the questions from that one. There was one about the tail club. I'm going to put that back up. Here we go. An 11-year-old wants to know about the function and size.
Icarus tail club. Who wants to take it?
I could take a stab here. So this is Doedicurus is a lousy fuzzy mammal trying to be Ankylosaurus. No, just kidding. It's a sort of giant armadillo called a glyptodont. And this is the sort of extreme version because like the club-tailed dinosaurs, it too has this great big, massive, stiffened end of the tail that comes out to this big knob, and there's like pits on it that suggests there may have even been like spiky knobs coming after that end. And there's the tendency for people to think, well, if you've got a big weapon like that, it's used to fight against an attacking predator. And sure, it almost certainly did that. If one of the big saber-toothed cats or a pack of wolves or something came by, then sure, you're going to use it. But a lot of time, and some of the others can talk more about this in a bit, a lot of time weapons in animals are mostly used against other members of the same species. And they use them to fight together, maybe for space, or maybe if they're trying to impress a mate or something of that nature. But I think probably that it would use it against whatever was making it angry at that time, whether it's another Doedicurus or an attacking Smilodon.
I think this next question's for you, Dave.
Yes, I saw that one. So the two answers are inevitably yes and no. So fossils in London, actually there are plenty of fossils in London because of the Thames, but they're not Mesozoic, so they're not age of the dinosaurs. But we do actually have some really good birds from, I can't remember the date now, but the last about 30 million years old, I think, give or take, which are of course technically fossil dinosaurs because birds are dinosaurs. In terms of have we got actual fossils that you can dig up out of the ground of Brachiosaurus and Diplodocus, Stegosaurus, sadly not. However, the UK isn't bad for dinosaur fossils. There's quite a few given just how tiny island we live on. But also we have the Natural History Museum in London, which along with the Smithsonian and the Natural History Museum in Paris are widely regarded as the three great natural history museums in the world. And so we do have quite a few dinosaurs there because British paleontologists have collected them, or over the years, the museum has bought them. So while Burpee and Museum of the Rockies and even some relatively small museums in the US have way bigger dinosaur collections because they have so many dinosaurs locally, they can just dig them all up. We have a really pretty good collection, given that dinosaurs are not that common in Europe, and I go there semi-regularly to study them.
Thank you.
Well, I think I'm going to throw this next one to you, Scott, considering you're at the MOR. Triceratops, an adult Triceratops, or Torosaurus, an adult Triceratops?
Okay, so that's a great question. So I'll preface it with a couple of things. I think it was Dave Evans, a paleontologist friend of ours, who once said that Museum of the Rockies was the house that Triceratops built. We have the largest collection of Triceratops, I think, in the world. We have well over 100 specimens of Triceratops. Many are very complete specimens, and we have growth series from little baby Triceratops to juveniles to subadults all the way up to adults. Several years ago, my friend, the curator, Dr. John Scannella, published a paper positing that Torosaurus, the large horned dinosaur that we see in the Hell Creek Formation that has the big openings in its skull, what we call fenestra, was actually a very old, mature Triceratops. And the lines of evidence include that if you look at other Triceratops that we all recognize are Triceratops, they don't have the holes in their frill. You can actually find that those areas, the frill is starting to thin and get, like, in some places, like less than a centimeter thick, whereas the rest of the frill, the outside margins, are, in some cases over 2-3 centimeters thick. And so what's interesting is here in the Hell Creek, we don't find any juvenile torosaurs. You would expect to find, here's a cute little torosaur skull with these little openings in the skull and so on and so forth. We don't find that. So you take that bit of evidence, you take the evidence that I talked about where you have the thinning frills on the Triceratops, you put them together, and that makes for a pretty strong case that Torosaurus is very old. Also, Torosaurus is very rare, and you would expect that. I mean, very old, mature dinosaurs are going to be rare. It takes takes a lot of luck to make it that late in life for pretty much any animal when you think about it. And so one of the things that we're doing right now, or what John's doing, is he's cutting up Triceratops. And you may say, what do you mean cutting up? That sounds like a terrible idea to take fossils and damage them. So paleohistology is a field of paleontology that has grown over the last 20 years, where you can cut bones, basically cut sections out of long bones like your leg bones, femur, tibia, and you'll embed them in a plastic resin, and then you'll cut them even thinner, and then you basically sand them down. You grind them down so they're super thin, and thin enough that you can pass light through them. And when you do that, you can see a whole bunch of information in the bone. Here I have a picture. This is actually of a T-Rex bone. This is a cross-section of one of those thin slices of bone that has really been polished down, and light is being thrown through it. And you can actually see here growth rings. These are rings that indicate yearly growth. Almost all vertebrates record their growth in their bones. So we can look at that and say, this T-Rex, Jane, is 13 years old and still growing very quickly. Therefore, Jane is a juvenile T-Rex and not a Nanotyrannus. That's my segue on that. But we are looking at doing the same things with Triceratops. Here is an actual piece of this. You can see how thin this is, right? This is a slice of a T-Rex. John doesn't want me to share any Triceratops stuff because he's super excited about it. Thank you. And Ellen Lamb is here helping me. She's our histology lab manager. So I'm going to try and, if you can you see through that?
Yeah.
That's bone, right? So we can actually throw light through this, and we can look and see, that's perfect.
Yeah.
We can see through that bone, we can see growth rings, we can see vascularity. If there's a whole bunch of openings in the bone, basically these little holes, these little vascularities here, those are called Halverson canals. Those are where blood vessels go through. If there's a lot of them in a very small area, that implies the bone is growing very fast because all that blood nutrients are going to the bone. Bones are living things, right? And so what we're doing to further test our hypothesis that Torosaurus is an old, mature Triceratops, is we're cutting a whole bunch of Triceratops bones. We're sanding down those bones so they're super thin like this, and we're going to throw light through them, and we're going to look for growth rings, how many blood vessels we're going through them, all those vascular canals, and see how they're going. And we're making some pretty cool things. I know some things, but I can't share them with you. So that's one of the things. Museum of the Rockies kind of helped pioneer a lot of the histology work that is going on. And all the students that were here, in the late 90s, 2000s have now moved on, and now they're teaching their own students. That's one of the great things about universities and museums is it's kind of like Star Wars. You've got Jedi Masters, they teach their Padawans become Jedi Knights, and then they become Jedi Masters and teach their own Padawans, right?
So then what are you?
Unless they become Sith.
Well, yeah.
By working on mammals.
That's wrong.
I don't know what he's talking about, Julie. So does that answer the question on Torosaur?
I think
You nailed it.
got it. We're going to go to LMA. Would like to ask if they have found any dinosaurs in the Arctic. And yes, they have.
Yes, lots.
The North Slope of Alaska, kind of like Tony Fiorillo, Pat Druckenmiller, I think maybe even Greg Erickson and a number of other researchers have been pulling a lot of dinosaurs out of the North Slope, and even Tyrannosaurs, I believe.
Nanooksaurus is from up that way, yeah.
Yeah, Nanooksaurus, that's right, yeah. So dinosaurs are found on every continent.
Well, and Antarctica as well, where you've been. So, yeah, it's not just the Arctic, even the Antarctic.
Yep. So, they're found on every continent, pretty much all environments. Anybody else want to contribute?
Not sure there's much to add to that.
Yeah.
Yeah.
No.
You get dinosaurs, absolutely. Yeah. I think the record's now about 180 countries.
Wow.
Mhm.
And there's about 225, 230 countries, give or take. And remember, a lot of those are very, very small, and a lot of those are islands, which are not good places for fossils. So we really have found them just about everywhere.
We got another one. How many dinosaurs have you found from? Well, how many dinosaurs have you found?
Yeah. I don't think we found any in Brenner Marshall Elementary. I keep looking, but that's
It's too bad. I'm sure the kids at Marshall would wish there's some.
So another one asked if they've been found on Mount Everest.
yeah. We've named, so scientists have named about 1,500 species, give or take. There is no definitive list, and as we've just seen with Triceratops and Torosaurus, people disagree over exactly how many there are anyway, but lots. And then how many individual skeletons? In terms of good ones, a few thousand. In terms of very fragmentary ones, many thousands. In terms of teeth and bits, probably hundreds of thousands. Would be my rough guess. I don't know if anyone wants to second guess or dispute that. But yeah, I mean, most dinosaur skeletons are not complete. They're bits. But we have some things like Psittacosaurus, the little parrot-headed early ceratopsian from China. There's a couple of thousand fairly complete skeletons of that known. So you have everything from species known from thousands of good complete skeletons down to, there was a new dinosaur named this week off a single metatarsal. So here's a cast of a velociraptor foot. These are the metatarsals. One bone was enough to name a new species. Now that's a bit exceptional, but that's the range of dinosaur fossils that we have.
I'll just jump in too and say that because I think a lot of kids especially don't understand, and even adults, that when you find a dinosaur bone or anyone else or any other kind of fossil, we don't just dig down and find a fossil. Unless 100% there's a fossil down there, which is really, really rare. So what happens? Yeah, that's true. So what usually happens is that an animal died a long time ago. Hopefully it died near water, and then some dirt in the water can cover it up really quickly because nothing can be around to eat it. Bacteria can't eat it. It has to be buried really fast. And then it's buried really, really far down deep because there's tons and tons and tons of dirt that gets added on top over millions of years. And then, so those bones are really far down. So we don't just dig down. What happens is that usually they're caught up in some sort of mountain building event, and the dirt gets pushed up to the surface. And then as paleontologists, we know kind of how old those rocks are and that there might be some fossils around this area. So we just literally walk around until we trip over it. And then you know that there's probably some bones there. And then you can start digging around. But we don't know exactly where things are and then dig down. So a lot of it is just luck for how you find things.
Get to this Everest one. After this.
You want to go back to the Everest one?
Yeah, I don't think we really answered it.
So before we do, oh, I'm muted. No, I'm not. So guys, this question, I feel like it's, it could start a little bit of a fun time. So I'll just leave that there.
I'll start off. I mean, it's pretty easy to say like things like, hey, there's some really big museums that have amazing collections and have amazing exhibits, right? The American Museum of Natural History in New York City. If you're in it for dinosaurs, whatever. But they also have an incredible fossil mammal collection exhibit. It's outstanding. The Carnegie Museum of Natural History in Pittsburgh is another place. Obviously, the new exhibit at the National Museum of Natural History in the Smithsonian. The National Natural History Museum of London has some great specimens and some awesome historical specimens as well. Let's see, the Field Museum in Chicago, Science Museum in Minnesota, obviously Museum of the Rockies, Denver Museum of Nature and Science, Natural History Museum of Utah, Los Angeles County Museum of Natural History. These are all great places. There's if you're looking for fossil mammal material, if you're a friend and a fan of mammoth, you need to go to the Natural History Museum at University of Nebraska, Lincoln, Nebraska. Outstanding collection there. And if you are like hardcore, hey, I'm only about the dinosaurs, then you need to go to the Royal Tyrrell Museum in Alberta, Canada. Now, those are just a handful of the big ones that I just threw out. Don't discount the smaller mid-sized museums like Burpee Museum, because they are full of great specimens and people with lots of heart. There's the Carter County Museum in Ekalaka, Montana. There's the Sam Noble Museum down in Norman, Oklahoma. There's a whole slew of mid-sized museums that really contribute to science, contribute to education, and certainly need your love in this pandemic right now. So it's very hard to say this is the best museum I've ever been to. Every museum I go to, I see something new. I see something that goes, oh, that's cool. That's a different way of doing that exhibit, or that's a cool specimen I didn't know they have. So you should go to all of them as often as you can.
Mm-hmm. And I note the Robert Moore put the statement in about the Tianyu Museum in there, which actually leads to an answer to one of the other questions. What is the most common dinosaur fossil? So, including birds, then there are some bird species like Confuciusornis and some of the Cenozoic birds for which we have literally like tens of thousands of specimens known. But for non-bird dinosaurs, this is finessing whether it's a bird or not. Anchiornis is known from hundreds of specimens, the vast majority of which are not described, but the Tianyu Museum has a huge number of them. Psittacosaurus, Dr. Hone mentioned before, we have vast numbers of that. Maiasaura, the duckbill, and Centrosaurus, one of the horned dinosaurs, are known from bone beds that cover tremendous areas. So there's thousands of individuals, although they're not all collected, and we don't have them together as single skeletons. And then there's creatures like Dr. Hone just mentioned, that are known from a single foot bone. So there's a whole spectrum in between, and that's true for all the fields. It's true for proto-mammals. It's true for mammals. It's true for all the different groups of fossil creatures. Some of them are super common. Some of them are incredibly rare, and we get super excited when, ooh, this toe bone or this finger bone is slightly different than every finger bone previously found. I'm going to name it a new thing.
Hey, Josh, do you want to start this one?
Oh yeah, someone's asking what large fossils can be found in Illinois. Well, it depends on where you are in Illinois. Here in northern Illinois and southern Wisconsin region, most of your bedrock here is Ordovician in age. You're talking 450 million years old. So the kind of fossils you're going to find in there are invertebrate fossils, so the squishy things that lived on the bottom of the ocean, or the bivalves, crinoids, trilobites, if you're lucky, things of that nature. However, on top of the Ordovician bedrock is all Pleistocene material, and things that lived during the Pleistocene and are relatively common in the Midwest are things like mastodons and mammoth. You can find bison fossils. Here in Illinois, we've got several mammoth specimens and mastodon specimens. Yeah. Surprisingly, not surprisingly, but around the Chicago area, if you find a lot. Southeastern Wisconsin, Kenosha, Racine area, you get these mammoth and mastodon specimens. But basically, around here, anywhere streams and rivers are cutting through these deposits is where you get these fossils that will fall out. I'd say one of the most common things for mastodons and mammoth are their molars. Their molars are very, very hard, and a lot. You'll talk to a lot of old timers who will use them for door stops and things like that, and maybe not even know what they are. But when people bring these things in, it's notably mammoth or mastodon. And if you're in northern Illinois, we are currently working on an Ice Age exhibit here to kind of highlight the things you can find around here. Kind of one of the things that we've always, as I think in museum workers in general, paleontologists, people call us up all the time and say, hey, we're digging in the backyard and we think we find a dinosaur bone. Well, here in Rockford area, you hate to have to break it to them, but the chances are they're not finding dinosaur bones. But it doesn't mean they're not cool. It doesn't mean they're not important to illustrating the animals that lived here long ago. So that's why we were doing this exhibit on the Ice Age mammals and fauna around here, is to show people that, yes, you're in Rockford, you're not going to find dinosaurs, but if you're out playing in the backyard and you find something that looks like a fossil, it's likely an Ice Age mammal of some sort. So we're hopefully going to be getting that up here in the next few weeks. So if you're in the Rockford area, and once we open, come see our new Ice Age exhibit, because you'll see some of the fossils that are found
Hey, Josh.
in this region.
Speaking of, oh, sorry.
Scott had a real question.
Let me just follow up real quick, because the natural question that follow that is, are there any dinosaurs known from Illinois? The answer is no. As Josh said, the wrong kind of rocks are exposed throughout most of Illinois, except down the southern tip. The very southern tip of Illinois, you have Cretaceous age rocks called the McNary Formation. However, most of that formation is covered. It's very foliated down there, so you have lots of forest, trees, shrubs, things like that. So that's covered, and so when that stuff's covered, it doesn't erode. There's just a few areas where the river, I think the Illinois River and the Mississippi cut into it, or actually it would be, I think, the Ohio River, there have been paleontologists going down for years, sifting through some of the gravels and sandstones, hoping they'll find a shed tooth or something like that. They have found plant fossils and I think some wood, but nothing serious yet. However, if you go across the Mississippi into Missouri, there's a site called the Kronster Dinosaur Site, which has some amazing duckbill dinosaur specimens. It's a clay pit, a marl pit, and it was first collected back probably not going on 20 years now. And I know the Field Museum has been there fairly recently, collected some amazing stuff. So the answer is, we don't have any direct evidence that dinosaurs were in Illinois, but by inference, they were. If that makes sense.
I'll just jump in really quickly too, because I grew up around here. I'm from Dubuque, Iowa, so right in sort of where Rockford is too. And I collected fossils my whole time growing up, and I loved going outside and looking at rocks and grabbing fossils. And so any of the kids listening, you can definitely just go outside in your backyard and find fossils every day if you want. As long as there's some rocks around, you can find fossils. And one of the best places to do that as a little kid, especially, is if you're outside in the pea gravel that might be around your school. If you look at those little rocks, and especially if you see it looks like a hornet's nest or bee, like honeycomb, that is a fossil. That's fossil coral. And so every rock that you touch out there when you're just playing in the playground is super old, and a lot of them have fossils in them, especially like ocean fossils. So you can find those every single day.
And I can sort of tie this to a question that's been asked a couple times about the fossils on Mount Everest. Now, I've never been to that part of the world, so I myself haven't found these. And I'm no mountain climber. But the fossils that are found on the top of Mount Everest are actually just around the same age as the fossils Dr. Hellert was talking about. They're from what's called the Ordovician, which is early in the Paleozoic, and they include fossil corals and trilobites and these sea lilies or crinoids and brachiopods. And those are very similar fossils to that many of us, maybe near many of us. I mean, I could drive an hour and find similar type fossils in Western Maryland and so forth. So, but it's as they were asking in the question, it's what's happened when the plates come together. It pushes stuff that was once at sea level and had turned to rock, squished it way up. So now it's the highest spot of the world. But when it formed, it was below the level of the ocean.
Hey, Julie, we're getting a lot of questions where people are just asking more questions about the wolf pup. And one of the things they keep asking is, can they see it? So I've got the National Geographic article up here. And if it's okay with you, I'm just going to share that photo from that article. Is that all right?
Yeah, absolutely. Also, if you want to see her in person, you can. So you may want to wait until the pandemic is over, but she's actually on display at the Yukon Beringia Interpretive Center in Whitehorse, Yukon. It's kind of a trek to get up there, but she is on display, and she is really cool looking. So you can actually go see her in person too if you want.
Awesome. Awesome. All right, let's get another question up. This is actually, we've gotten a couple people asking about wanting careers in paleontology and looking for advice.
If I can dive in quickly. So I wrote a long piece about this on my blog a couple of years ago because I just get asked it so often. And although obviously I'm not in America, and American high school and university is a little different to the UK, I think a lot of the same points apply. So I will dig that link out in just a second and dump it in the chat. But there's several pages of ideas and links there, which is probably more effective than what we can talk about in 3 minutes.
Yeah, and I will also add that there's actually several avenues that you can get to paleontology through. You don't have to be a geologist. I'm actually not at all. I'm not trained in geology one bit. I'm an anatomist, so I came through the biology route. So you can come at it through biology, you can come at it through geology, or you can even come at it through anthropology, depending upon what your interests are. So there's several different ways to kind of get there.
Mm-hmm. And Dr. Hellert, her research, you use a lot of math. You do a lot of math and shape analysis. So any sort of science you can apply to fossils in one way or another, and you're doing paleontology then.
Yep. And I would say also that, especially if you're like, you start your real traditional training for paleontology in college, but you can start before then by just looking around. Use your eyes as much as you can and your brain. So every time you're outside, look at the ground. Just look at the ground and look at the rocks and see if you can find those fossils I was telling you about in the pea gravel. See if you can see differences in the rocks. The rocks can tell you a lot about the fossils that you find in them. So then you start to learn the story behind what is this animal or plant? How did it die? Why is it there? What is the ground that I'm standing on? What did it used to look like? That's how I got into paleontology, is that I found out that the rocks on my farm used to be at the bottom of the ocean. And I thought it was so cool that the farm that I'm on, my house that I'm super used to walking around, used to be an ocean and look way different than it does now. So you can tell, just like use your eyes, look around on the ground, and get used to finding interesting things.
And I also want to jump in and add too, if you're near a natural history museum or any museum for that matter, volunteer. If you get the opportunity to volunteer, when I was a kid, I loved dinosaurs, I loved paleontology, but I really wasn't connected to that paleontology network. And it wasn't until I actually went to grad school and was told by one of my professors about the Berkeley Museum. So I came up here, I cut my teeth for 3 hours a week for a long period of time with Scott, and that really opened me, got my foot in the door to networking with all these other paleontologists, and that's what paved the way to where I am today. So I mean, you don't have to do a lot; just get in and get your foot in and start seeing what it's all about. And then maybe if you're lucky, you can get in on some research projects and then and figure it out. So if you have that opportunity. Maya, you're doing it already. You're coming in all the time when we're open. You're taking the right steps right now to become a paleontologist. So keep it up.
And one more quick thing too is that because I do so much math, a lot of people, when they talk about any kind of STEM career or thinking about going into science, it's kind of scary because maybe science is a little bit hard for you or math is hard for you. But it doesn't matter. You get good at the things that you have to be good at to do what you want to do. So I am not a math person, but I make up new math now, which is crazy. So you don't have to be good at it. I wasn't great at math in school, but I needed to learn that math in order to do my job. Same thing with computers. I knew how to use a computer, but I didn't really know how they worked. And now I have to write computer code and do all of this stuff every day that I never thought I would be doing. So even if you don't think you're very good at it, it doesn't matter. You'll get good.
The other thing I'll say is I'll jump in. I started volunteering at Burpee when I was 13. And I did it for I don't know how many years and then just kept involved. So volunteerism is super important. Now, if you don't have that luxury of having a museum in your backyard, that I would certainly recommend getting involved in like this kind of stuff, virtual learning, going to events when it's safe to do so, PaleoFests, DinoFests, things like that. And keep in mind that as you're going through school or high school, you know, you're going to want to take, if they offer an earth science course, you know, biology, zoology, you know, even botany if they have it. You know, there's going to be some math, but keep in mind that you don't have to, if you are interested in paleontology, you don't have to end up becoming a PhD professor or curator. There's a lot of other avenues in paleontology. You can be a fossil preparator, you can be a collections manager, you can be an educator, you can work for the Park Service, you can work for the Bureau of Land Management. Paleontologists are everywhere, surprisingly. I tell people many of our medical students today, Julie, are being taught by paleontologists, because we're the ones who understand anatomy and comparative anatomy and things like that. Some of the best fossil preparators I know have an art background. So keep that in mind. Connie Van Beek at the Field Museum, a great preparator. She's got an art degree. So there's many different avenues, and that's why you should go to things like PaleoFest, because you can hear from all these different people that have different backgrounds, have different professions, and had kind of got into the profession in different ways.
All right, and Carter's asking, do they have dino dig sites that kids can join in? And I will say yes. In fact, we here at the Berkeley, we do run programs every summer out to Montana and Utah. In terms of our expeditions, there Montana not as much, simply just because it's just of the terrain. However, our quarry out in Hanksville, Utah, it's a large dinosaur quarry, and it's a dirt road. It's a county road, actually, out in the middle of the desert. But it leads right up to our quarry. So in the summer, when we bring people out, we have opened that up to families, so they can come out, and we train, you know, how to use the tools, and we oversee to make sure, you know, care is being taken. But yeah, so there are opportunities out there for kids to join dinosaur digs and other fossil things. A lot of programs also used to doing here called family fossil field trips to local quarries where, you know, kids can come and they can collect fossils. That with liability insurance and stuff like that, a lot of quarries don't allow that anymore, but some do. So if you're in an area where there's lots of, especially limestone quarries, see if you can find a gem and mineral society or something around you that will allow you know, to join them while collecting.
Well, our time is running out, so I want to first and foremost thank all of our speakers today. They will be returning this weekend on both Saturday and Sunday to be part of our PaleoFest. So the Student Symposium was just a little discussion, opportunity to answer questions. The main meat and potatoes of everything that's happening with PaleoFest is still yet to come. So join us. You can go to berkeley.org to learn more. Get tickets, join us on the platform. There'll be lots of different rooms you can enter, lots of different activities you can do, and certainly a whole lot of paleontology fun. So thank you guys. Yeah.
I'm just going to add one more, answer one question real quick. Someone asks, is there a good online resource where you can see good images of dinosaurs, especially new ones? If you want to know anything about new dinosaurs, follow Dr. Tom Holt on any social media. New fossils are coming up. He's gonna put that out there.
He's not kidding. I find most stuff from my stuff from following Tom.
I don't believe that Tom
as well. So on his blog, so
he'll post things at 3 a.m. I don't think the guy just nonstop 24/7.
So at Tom Holtz Paleo.
All right. Thank you, everybody. Thank you to the speakers. I really appreciate you joining us. Thanks, everybody, for joining us and asking questions. You guys have a wonderful late afternoon.
All right. Thanks again for everyone being on.
Bye-bye.